Hello everyone, let's solve next question. The question states that we are given the displacement time equation, which is x is equal to 20 plus t cube minus 12 times t in SI units. The particle is moving along x-axis and this is the displacement time equation. We have to find the position and velocity of the particle at time t is equal to 0. This is the first part. The second part it asks whether the motion is uniformly accelerated or not. And the third part asks us to find the position of the particle when velocity of the particle becomes zero vector. Let's first find the equation of velocity and time, the relation between velocity and time from this equation. So we have v is equal to dx upon dt. So we are getting 3t square minus 12, and this will be in meter per second. Now let's solve the first part. Here first we have to find a position. From this expression we can easily find the position at time t is equal to 0. Now, x is equal to, we can put here t is equal to 0, so we will get 20 plus 0 cube minus 12 times 0. So this is equal to 20 meter. Now we have to find the velocity of the particle at time t is equal to 0. So we can write from this expression v is equal to 3 times 0 square minus 12, which is equal to minus 12 meter per second. That means if we consider plus x direction as positive, then the velocity will be directed in a negative x direction at time t is equal to 0. Now let's move to part B. In order to state whether the motion is uniformly accelerated or not, we have to find the expression of acceleration. We can find A is equal to dv by dt. And from this expression we will be getting 3 to the 6 times t meter per second square. This will be the term of acceleration. And we can clearly see that acceleration is dependent on time. That means acceleration is not constant. This is not constant. Therefore, this is non-uniformly accelerated motion. Now, let's move to the third part, that is question number C. Here we are asked the position of the particle when the velocity of the particle becomes zero vector. Let's first find the time when velocity of the particle becomes 0. So we can put here v is equal to 0. So v was 3t square minus 12. 3 times t square minus 12, it is equal to 0. So we are getting t square is equal to 4, or t is equal to plus minus 2. T cannot be negative because it is time, so t is plus 2 seconds. That means at time t is equal to 2 seconds, the velocity of the particle will become zero vector. So we can find, therefore, the position of the particle at time t is equal to 2 seconds. T is equal to 2 is equal to, this is the expression to find position, the 20 plus 2 cube minus 12 times 2. So we are getting 20 plus 2 cube 8 minus 12 to 24. So 28 minus 24, that is 4 meter. This is the position of the particle when the velocity of the particle becomes 0. That is at an instant t is equal to 2 seconds. Thank you.